Kinetic molecular theory of gases. So this is a model. Did not mean to do that. So with gases, we've been talking about what happens. We have not discussed why. And in science, the what always comes first, because you can't explain something until you know what it does, right? Because you see something happen and you're like, why does that happen? But first you have to see it happen. So kinetic molecular theory is the currently accepted theory for why gases do what they do. So postulates, ideas, concepts. So the first idea is that gases consist of tiny particles. You're like, oh, wow, that's revolutionary. Well, it was revolutionary when they first came up with this. So gases are tiny particles. Those could be atoms or molecules, but gases are tiny particles. The particles are very small. They are so small that compared to the distances between them, the volume, the size of the actual particles, doesn't matter at all. It's negligible, which means you can neglect it. So it's essentially zero. So the particles are so small relative to the vast spaces between them that the size of them doesn't matter. So we used to drive to Minnesota every other year with a van full of children, and we actually enjoyed it, strangely enough. But I remember the first time we went through Wyoming. This was back before cell phones, and we had our AAA guidebook, when you're reading, because it's a stinking long ways to Minnesota. You drive for days and days, and it's a good way to get a grasp on how enormous the country is. You just drive and drive and drive for days on end and only get halfway across. And you're like, oh my goodness. You don't get that effect in an airplane. So I'm reading about Wyoming as we're driving through it at night. And the population of Wyoming is approximately the same as the population of Fresno. Not Fresno and Clovis, just Fresno. Okay, so 440,000 is the number I remember. So a little over 400,000 people in the entire state. And this isn't a little tiny state like Delaware. This is a reasonable sized state. Not as big as California, but it's a good sized state. There's just not very many people. And when you drive through there, you believe it. Because here in Central California, when you drive at night, you see lights. Even, you get out of the towns, but you see farmhouses all over the place, right? In Wyoming, you can drive and drive and drive and not see a single light. And this is along the interstate, There's just nothing there in many places. It's just empty. Then there's these little pockets of population. It is kind of scary because we're used to being, around people. So Wyoming is a little bit like the gas state. You probably were wondering where I was going with Wyoming. So in Wyoming, we have a few people in this big volume, this big area, say. So does the size of the people in Wyoming really matter? If they were all 600 pounds, would they still fit in the state? Yeah, there's plenty of space. If they were all just skinny little things, it just doesn't really matter. Now, if you get people in an elevator, you've got 10 people in an elevator, now it matters, right? Because elevators, just a regular sized elevator, you're just like, trying not to touch other people because, you're not supposed to do that. But that's more like the solid or liquid state where the particles are so close that they're pretty much touching each other. Now the size of the particles matters a great deal. If everyone in the elevator was 600 pounds, the people wouldn't fit, right? Or if they were all 2-year-old children, there's a big difference. But when the container is so big relative to the size of the particles, the whole state of Wyoming and 400,000 people, it doesn't matter. So for gases, it doesn't matter if you have helium, which is a little tiny, or xenon gas, which is a big molecule. It doesn't matter because there's so much space in between. So that's what this postulate is. Third idea, the particles in the gas are in constant random motion. They are moving. And they are colliding with the walls And those collisions are what cause the pressure that's exerted by a gas. How does a balloon stay open? Well, you blow air into it, or you pump helium gas, some sort of a gas into it, and why does it stay open? Because the gas particles are hitting the walls of the container and causing a pressure. The particles, we assume, do not attract each other or repel each other. Now, in Wyoming, the people are not spread out uniformly. They are clumped up. You know, there's a bunch of people up by Yellowstone, and then there's Cheyenne, and they're kind of clumped up. But if you imagine them just spread out, they're so far apart from each other that they can't interact with each other. You know, the next person might be way over there, and you could yell, and they wouldn't hear you. So how can you interact when you're so far apart? You can't. The particles in a gas are so far apart from each other that they don't interact. The average kinetic energy of a gas is proportional to the Kelvin temperature. So we talked about temperature and how it's a measure of kinetic energy, which is related to motion of the particles. So the equation for kinetic energy, which you do not have to memorize, we won't use this, I just want to show it to you so we can understand. Kinetic energy is 1/2 the mass of the particle times its velocity squared. So the mass of the particle doesn't change. A gas particle has a certain mass, it's not very much, but it has a mass, and that is constant. So what can change? The velocity. If you have more kinetic energy, it means the gases are moving faster. If you have less kinetic energy, they're moving slower. So low temperature, they're moving slower. High temperature, they're moving faster. Have I talked to you guys about the barefoot people on the beach? No? Yes? Yeah, so hot sand, think Wheatley Beach in August. Hot sand. Are you just going to walk barefoot to the cold water? You're going to burn your feet on the dry sand, hot dry sand, right? Hot, so you hot-foot it, right? Real fast. But if you go to Pismo, where it's like 60 and overcast and windy all summer long, which is why we go there, because it's cold, you can walk along barefoot and you just stroll because it's not hot. So cold, moving slow. Hot, moving fast. So this helps us to understand the meaning of temperature. Did I skip? Oh yeah, that's a new section. So we'll start.